Alright, are you ready? This joke is hilarious. Alright, a horse walks into a cafe. The waitress says, "Hey." To which the horse replied, "Sure." It's hilarious. So funny. If you don't get it, rewind it and you'll figure it out. Alright, here is your frame for today. It looks like this. Alright, so our key topic is real number solutions. Real number solutions is about understanding the solutions of real number operations. Remember, operations in math mean that adding, subtracting, multiplying, dividing. So we're going to start with some adding. Wow. Okay, so with adding, what we're talking about is if we take a rational number and add another rational number to it. Okay, remember in this video, our basis of what a rational number is if we can write it as a fraction, okay? Even if it's a repeating decimal or it's a terminating decimal, we can always rewrite that as a fraction. So whenever we have a fraction like a over b plus c over d, just say we have these two fractions that we're adding together. Whenever we add two fractions together, we're always going to get some other fraction. Whenever we can write it as a fraction, it's a rational. So a rational plus a rational always ends in rational. Really easy, because rational you can write as a fraction. Fraction plus fraction is always going to equal another fraction, even if those two fractions aren't the same. Alright, so then we have rational plus irrational. Alright, if we take something that ends or terminates, or it can be written as a fraction, that's rational, and add it to something that never ends and never repeats, is adding something to it going to change that? No. So rational plus an irrational always ends in irrational. Because if you have a number that never ends or never repeats, no matter what you add to it, it's going to always, it's still not going to end, and it's still not going to repeat. Okay, an irrational plus an irrational is still going to be always ending, always ends in an irrational. Okay, does that make sense? Because if you add something that never ends, never repeats, to something else that never ends and never repeats, together you're just, when you add them and you put them together, you're still going to get something that never ends and never repeats. Alright, our next one is subtracting. Alright, I'm going to try that again. Subtracting. And with subtracting, we're going to remember that subtracting is adding the opposite. So really a rational minus a rational is going to be adding a negative rational, which is still rational. And then we're back over to our adding, where rational plus even a negative rational is still a rational number. It's just the opposite. So this is going to end up solution is rational, is always rational. Alright, again, same thing here. We're going to change this as adding a negative. The opposite of an irrational is still going to be irrational. Just because you're making it negative or you're making it positive, it's still going to end up being irrational. So it really just makes sense, again, that this is just rational plus irrational. So solution, again, is always irrational. going to get the same idea when we do irrational minus rational. We're going to change this to adding the opposite. The opposite of a rational number, whether you're changing it to a negative or a positive, it's still rational, okay? Because if it repeats or ends, if the decimal repeats or ends, or can be written as a fraction, you're just making it negative or you're just making it positive. Still repeats or ends or is written as a fraction. So when you add something that it doesn't end and doesn't repeat to something that ends or repeats, you're still going to get something that doesn't end or doesn't repeat. Alright, and then finally you have irrational minus irrational. And this one is a little bit different. Okay, so irrational plus the opposite of an irrational. Usually, solution is irrational. The only case where this is going to not be irrational is if you're doing something like pi minus pi. What's pi minus pi? 0. That's the only time that this is going to be something that's a whole number. So if you're doing the same number minus itself. Alright? Then we go on to multiplying. Alright, with multiplying we have rational times irrational. Remember that means that rational can be written as a fraction. If we do AB times C over D when we multiply, we just get A times C on top over B times D on bottom. That's how we multiply fractions. We multiply the numerators, multiply denominators. So we get a fraction. So your solution is rational. Alright, we go down to rational times irrational. So that means we're taking that irrational and we're just adding it to itself as many times as the rational says we will. So when we add an irrational to itself so many times, it's irrational plus irrational plus irrational plus irrational. We're going to end up with an irrational. Okay, so solution is usually irrational. And the only time it's not irrational is if you do 0 times irrational, an irrational number. Because when you do 0 times anything, you get 0. That's the only rational number that's going to change this solution is irrational. Alright, and our last example is irrational times irrational. Your solution is going to be irrational. Alright, we go to our last category, which is dividing. Okay, again for this first one, irrational divided by rational, we're going to use that idea of A over B, two fractions dividing. Remember, when you divide, you're multiplying by the reciprocal. And then you multiply numerators, and you multiply denominators. At the end, we get a fraction. So if we get a fraction at the end, that means our solution is always rational. Alright, if we do rational divided by irrational, our solution is going to be irrational. Unless our only exception is 0 divided by something. So if we say 0 divided by pi, that's always going to be 0. If we have 0 divided by something. That's the only exception here, okay? Our irrational divided by rational, that means we're taking a number that never repeats, never ends, and we're dividing it out into groups. When we divide that into groups, it's still going to be irrational. There's not going to be a certain amount that's going to go into it. So irrational solution, or solution is irrational. ignore that little scribble. Okay, and then finally we have irrational divided by irrational. That means we're taking an irrational number and dividing it out into an irrational amount. Okay, so we're dividing it out into different parts, but those parts aren't going to really ever make sense, so we get an irrational solution is irrational. Okay, your so what for today is, it's important to keep this in mind. To keep these solutions in mind. To check reasonableness of answer. So if you're doing something and your answer, you get like this ridiculous answer, like if you do 5 times 6 and for some reason you get this ridiculous answer that goes on and on and on and on and on and on and on forever and ever and never repeats, you should know that rational times irrational is irrational. So just to check your answers. Alright, have a good day. Bye.